All right. Just before we hit play here, just so everyone's aware, we're going to record this session today. Hopefully that's okay with everyone. If you have any problems, just let me know after the meeting. Um, and as we continue on through this meeting, there's a chat in the bottom of your Zoom there. If you have any questions, we're going to have little stops along the way and leave your message in the chat, and we'll get to those questions at the end of each little segment. So, Jeffrey, I'm going to get started now if you want to start recording.
Sounds good. We're good to go.
All right, great. Good morning, everybody. My name is James Bradshaw. I'm the CEO and co-owner of a company called Velocity Green. I'm actually here today in our warehouse. What we do here at Velocity Green is we sell biologicals and biostimulants. We brew live products, we manufacture, we distribute, and we also wholesale varying products. Today, what we're going to do is we have Scott Walker with us. Scott Walker helps with our research and data collection for our company. All the products that we sell here at Velocity Green do have a proven track record of data, and I think you're going to see some exciting information presented here today. We're going to open up with introducing a new product. Scott, if you could actually change that slide to the next one, please.
You betcha.
So these are the three products you're going to hear about today. Product we've been working with for the past 6 years here in Southern Ontario is ACF-SR. That stands for AquaClean for soil remediation. Another product that you're going to be introduced today is called Ligni-Leaf. And finally, there's one here at the bottom called AnneMaxx. So AnneMaxx is new to our lineup, but it has got 5 years of results in Western Canada, and Scott's been doing some trial with that product as well. So without further ado, I'm going to hand you off here to Scott Walker to present the different results we have with these three different products.
There we go. Thank you very much. Hi, folks. I'm Scotty Walker. I'm recognized by a company by the name of DSW Enterprises and Consulting. And what I've been doing for a number of years is doing the research and study of biologicals, biostimulants across Canada, fruits, vegetables, broad acres, apples, peaches, pears, and plums, corn, wheat, canola, things of the sort. So over the years, in particular since about 2010, I've really focused heavily on these particular types of materials, some which may be familiar, others may not, but they're in and out of the industry on a regular basis, representing a large array of different types of active materials. And in that process, I've been able to pull out a lot of information. Now, as we go through these types of products, let's keep in mind that what we're really trying to do is stimulate the plant and or, for the most part, that rhizosphere, so that we can reduce the pressures of we put on pesticides and reduce the pressures we put on our synthetic fertilizers. There's a homogeneous environment in that soil system that really is quite remarkable. It's a bound of many materials. And this slide is really just there, not for all those confusing words on the right, but the bar graphs. You'll see that there's different stages of this particular plant where those growth hormones, growth regulators, proteins, and enzymes, they ebb and flow according to different stages. So that means the plant is trying to upregulate certain materials at certain stages of its life. And really, in essence, in agriculture, regardless of what we're doing in the fields, this is what we're trying to influence in a positive way. And that's why it's so important to have a great deal of scientific background and information so that you can spearhead your efforts directly to get the right response. This particular slide is an ice cube. It really goes in line with the fact it's minus 30 this morning when I got out of bed. I live in Manitoba at the time, originally from Ontario. But as producers and industry people, we so often focus on that portion of the crop that is above the soil surface, because that's what we recognize, that's what we can see. But in actual fact, as we start to have a greater impact on that soil rhizosphere and all the elements therein, we can really have a serious impact. And that is really a case in point of what I've discovered over the last number of years. What I'm going to start with at this stage is introduce a company called AnneMaxx Soil Solutions, where they've been taking food waste and they actually create a recipe between the fruits and vegetables and eggshells from people that make egg whites and cardboards. and they put together a certain diet. And then they feed it to these worms and they go through that process of composting. In the end, what they've got is an all natural regenerative fertilizer because it's something they're attaining from all the waste in the industry, from recycling and stuff. Trying to influence that soil reserve with those materials, and you'll see why in a moment here, why it has such a great impact. This is a really nice picture to give you an idea the vastness of it. It's a factory. It's not some dudes in the backyard with a couple of pails of compost and throwing a couple of worms in there. They actually have a factory where they run with robotics because everything's precision done, and it produces an incredibly consistent material. And it's really quite exciting to be in a place like that and identify what's going on. This particular slide is in here so that you can understand they're doing 100,000 pounds a year. But one of the things that's really kind of cool is in this factory situation, as you can see my cursor here, there's this white area, and that's the density of the worm castings and the biosphere they've developed. If you were to throw, for instance, a poker chip on the top after it's been fed with this robotic feeder, it takes 45 to 60 days for that chip to make its way all the way to the bottom. So each day, those robotic feeders feed us a portion of food on top for the worms to process. And then that rhizosphere continues to do its job and cycle all these different materials till they scrape a teeny weeny bit off the bottom to the tune of 100,000 pounds a week. So it's a process, it's a manufacture, it's consistent, and it's labeled. They, of course, have a number of materials that come out of this. They've got their bulk material that's powdery and light and fluffy, and you can put it in your planter boxes or in light greenhouses. But to facilitate broadacre use, like there's a number of growers in Western Canada that have been working with this now for 5 years, and they're up to thousands of acres on their operation. So they need something like a granular if they're using a granular phosphorus as a starter. And then there's the liquids that are available where they take the solution of the worm castings and they liquefy it, and then they spin off the solids, and then they test it for regularity of their labels. And that, of course, means you can also get it in pails. Of course, in Western Canada with broad acres, there's a lot of people using the bulk bags, and they're using the tote tanks. There's even some producers are now buying it bulk in their dry trucks and their hopper bottoms and or their tankers. Like many other companies, though, as they get a base product, which would be their granular AMGR, and then their microbial liquids, which is the AM1, 2, or 3, then from there they start to spin off. If you look at their webpage, you'll see there's a consortium of all kinds of different materials. I was consulting with a couple of people yesterday because they like some of them blends have calcium in them and other things that they want to have a planting. So they have spun that off into a great deal of materials. How does this material work? So what my first years of replicator research, so my background is all about collecting data. So I always start with all those products you saw me list earlier in replicated study work. So I can identify and change some of the protocols if I'm not seeing the results that we want to. And sometimes it's just simply to see if that product's smoke and mirrors or if it's actually performing. So as you look at this data, you see all these marvelous numbers. But in my first year's replicated data work that I did last year at their request, I had 33 treatments in all between the liquids and the dries, and some were put down at planting, some were a follow-up. None of them, regardless of how much fertilizer I reduced, I removed the nitrogen down to as much as 35% reduction. And out of those 33 treatments, there was zero yield drag on any of them. The peas, on the other hand, like I see with a lot of pulse crops and specialty crops, when you get these types of materials, which are biostimulants, in the seed row at the root base, that's where you get your greatest benefit. Yes, you can broadcast them, but you can imagine when you broadcast, you dilute your efforts across a broad spectrum and you don't have the same focused approach. You can see here as well, they've got other ones where they're doing potatoes. This is actually out of Ontario, over and above all the broad acres they do. Now you'll see a 6% yield increase in it. And a field crop guy, he'd look at that and say, well, I hope that covers off my return on investment. But in potatoes, that 6% is hundreds of dollars an acre. And these folks, when they first started, they didn't touch anything along the lines of reducing fertility. They will be next year. They'll be adjusting some of the fertilizer programs so they expand their trials because they're a very large potato producer in Ontario. They'll gain more information and background on just how far they can reduce their levels of fertility. One of the really neat things I've seen over the last decade or so is the number of new lab testing formats that are coming up because we're looking at trying to find a more sustainable regenerative process to work with. So we need more information. So when these gentlemen work with this particular lab, they're starting to find out their water holding capacity, bulk densities in the soil, and above what we normally see in terms of organic matter and total organic harvest. They're starting to dive in to see what kind of microbial respiration and the levels of humic and fulvic acids. And then, of course, they do the classic cation exchange capacity of other, secondary elements and micros and the majors. But I want to draw this to your attention that there's so much more science now in the background that we can work with to either test and prove that we're having an influence on these different elements in the soil, and also to give you more background as to what you might want to do in your soil levels of different nutrition to create a higher return on your investments in all the elements that you put together. So as I close off that portion on the Annelida, I'd just like to ask if there's any questions, either in the chat. I see there's one there. If you could read it off to me, Jeff. And anybody wants to chime in with a question verbally before I move forward.
Yeah, I think the only thing in chat right now is just a welcome message.
Okay, gotcha. Well, I must have done a really good job of it. What this is all about. It's really quite remarkable, guys. I know I'm only into replicated data for a year because I really lean on that data information, but we're starting to move forward just so we understand how that works. If I have a control and it's on this series of plots, and I get 8 weights and measures, not 4 like many do, and if that was a control this year in canola, that exact same spot will be a control in a cereal crop, followed by the exact same spot in the year 3 with a pea crop. And it looks like they're expanding my contract to move that into even 5 years so that we can continue to monitor and test the different levels of application. So I can do these types of tests and actually monitor the change in that microbial respiration and the bulk density changing. Now I'm going to move into a product that Velocity Green has had great success with in the fruit and vegetable industry and some of the pulse crops and broadacres. This is a grouping of 5 specific bacteria. I first replicated work with these gentlemen, went back over 7 years ago, was on contract for 3 years with them directly. What I could identify was that it's not just, even though everybody says, oh, these are all bacteria, but everybody tells me I need more fungal elements in my soil. Well, nothing works in its own world. These materials, by the time they're brewed and you have all these amino acids and all these different growth regulators and hormones that are coming out of that, they actually spur and spawn the development of all the fungi that you want in the soil. But they're leaned towards that whole beneficial organism section. So when you influence one thing, it always has a spin-off to create more benefits down the road. And there's many industry members out there that will singulate these bacteria. And there's a number of products right now that are coming to the marketplace that are Bacillus subtilis, and there'll be a certain class there that they've seen good disease structures. These folks themselves, that gentleman there, John Wong, he's actually been working with a material to go down the path of PMRA work, where I did some work for him in North Dakota with the EPA, showing how these materials on different, a little different than this, actually we're controlling things like Fusarium head blight, and now they're diving into other diseases, and yes, even nematodes, which is going to be a serious, important thing. So I don't go on too long, just so you understand. Often we'll take an aerial photo of a patch, and this is the ACF on a field of hay that was treated. This producer is still using it on a regular basis, so where he's going into year 5, and you can see that there's a significant impact as you change that rhizosphere and create all this availability of all these micronutrients and secondaries and primaries, which you'll see here. This is after a 3-year work with 2 applications a year. You'll see that the non-treated area is still around that 19 parts per million of phos, in the 700 range of potash. Is a rich soil in Western Canada. But after 3 years of applications, undisturbed area, because it's a pasture land, which nobody's working and replanting, look at the levels and changes of the phosphorus and the potash. And calcium is hard to move because it's so soluble in itself, but there's a significant elevation in the nutrients. And when I first saw this is back in 2019, this is one of the triggers that really caught my attention to this product, and why I've worked extensively with the manufacturer for quite some time. Going forward in Southern Ontario, again, this product is, excuse me, is mostly used in the fruit vegetable industry, but some pulse broad acres. Now, again, I put this one on there because there's a full rate at 2.5 gallons with 2 soil and 2 foliar. And then we had a trial at 25%. The 25%, yes, it did have a significant impact, but not near as strong as impact of one season's use and changing the availability. Now, in some fruit industry, as we move down this road with multiple applications in one season, as I move the bar on that calcium level, does that equate into a fruit or in a vegetable? And yes, it does. And that can also lead to concerns and elements, things like the bitter pit issue and some of the varieties we grow today. And does that turn into different varieties? People say, oh, does it work on my ground? Does it work in my crops? Well, if we're having the right influence and we're changing that nutrient load availability and that whole rhizosphere is coming alive through the ACFs and all these other materials, then yes, it works anywhere. And I do work from all the way from the Okanagan Valley all the way out to the East Coast. And these products do, in fact, work in different areas and soil types and climates, varying degrees in different crops and varying degrees in different soil, but they all have an impact everywhere you go. Here's a vineyard, for instance, in the Okanagan Valley. You can see a little bit on the right there how we're changing the vigor of those vines. This was actually, believe it or not, a landfill site where they brought in all the subsoil. So the crop has had some difficulties getting established, but throwing the ACF-SR down there, we've stimulated the release of the nutrients. And even though there's virtually no topsoil there, we're still able to have an influence. And that can be seen again in the soil samples. So these are a lot of numbers. I don't want to overwhelm you with the numbers. The key to this discussion is that there's an impact over and over again from one place to another. And we did some work in Vineland Research Station on grapes still with one of the growers in Niagara region as a cooperator for the research facility. And those soil levels do in turn change into tissue levels, which in turn change right into your fruit production or your vegetable production or your grains. So it's not just a soil impact. We're actually pushing back on a lot of elements. And again, if you remember to one of my early slides, is if we are doing this correctly, we not only will change the pressures on these synthetic fertilizers, but it in turn equates to reducing the requirement for the pesticides. So as these products start to meld into your operation and you start to swing one end for the other and you get more and more confidence, you will in fact see less need for more fertilizer and you'll see less need for more of those pesticides. And that takes time and comfort as you move forward, but that in essence is what's going on. Here we have the fruit industry, a small strawberry producer, large producers, all different shapes and sizes. The key, what we hear over and over again, is that moderating the size. They're all very even in size. Their sugar content and bricks go up. But for me as a consumer, it's all of a sudden the berries are tasting like true strawberries, unlike some of the materials we get in the grocery store today that almost taste like wood. So we're having an influence also on the impact of the final outcome of that crop. And a lot of times it can be storage, whether it's an onion or a potato or a tomato or a strawberry or blueberry. As things move into the shipping system and get out to the consumer, our shelf life, our storage ability is much improved because there's a more balanced nutrition level. Now, this is a great photograph because in some areas, there's a lot of transplants that are grown for the strawberry industry, whether it's California or in Florida. These gentlemen right away could tell that all of a sudden when things went across the pack line, their benefits were that they had a better root system on every plant they kept. And now the crops, the plants that they were able to maintain started to increase their yield significantly just on the pack line. And that also turns into, instead of having 7 guys on the pack line, maybe we can go down to 3. So not only is there yield and these elements that we're trying to massage together, but there's all these other additives that come out as a positive return. I love the fruit and vegetable industry, if you heard me many times with this crop, because it has such a strong influence in that rhizosphere where if you get it used up front, right at early stages, you'll find that the developmental root systems that we cause problems with Fusarium root rot or Rhizoctonia or Pythium or Phytophthora, they don't get a chance to get a foothold. It's not so much that we're showing ourselves that we're getting all these disease control mechanisms. we're actually just interfering with its ability to establish itself and become a problem in production. So it comes down to the nuts and bolts again. Where's the yield? I'll be first to tell you in strawberry picking, if I can maintain the pickers to go into the right baskets and the right trailer all the time, I can get yield out of strawberries, but that's a hard number to get. Potatoes into a bin like a sugar beet guy is easy. This gentleman's been doing it. You can see he started in 20 and 21. He's still working with it to this very day. It's almost across his entire farming operation at this point. Then potatoes, because this is a live biological, there's an area in Alberta where these guys are using it on thousands of acres, but they don't put a lot of pesticides down the chute. If I could find cooperating growers or growers willing to put a separate tank on their planter and put it on there independently with a fertilizer, but no pesticide blending, because I really look at the return on that investment. I can do it with a pesticide, but I lose the efficacy and I start to lose return on investment. And that, in my world, as far as I'm concerned, in data, is critical. That nothing is going to be sustainable unless I can maintain this level of production and return on investment. So as I close off that section, again, there I see the chat box is lit up with a couple more questions. What would they be?
Yeah, so we got one here. After they started looking into more biologicals, discussing with other farmers, they noticed the benefits of biologicals under stress conditions, meaning drought year, but under optimal growing conditions, other farmers wouldn't notice a difference. And they're asking if we've compared our products to different weather conditions where they thrive, and does it always show a difference?
Okay, so the key factor, if you look at some of the photographs I've got of the ACF, we'll go all the way back to a hay crop that was dry. That's a dry crop. It works whether it's dry. It works whether it's got adequate moisture. Like Southern Ontario had plenty of moisture. The key is you look at these fruits and vegetables, a lot of them are irrigated. So Mother Nature doesn't have an impact. And these work extremely well in irrigation. As I break into the next product, I'll explain to you what I mean more by return on investment. And actually, it's a percentage of benefit on return on an investment, not, how many bushels an acre. It's not bushels, bushels, bushels. It's actually a percentage. So let's say I work with a farm in Saskatchewan, extremely drought country, and I'm looking for a return on that investment and a return on that yield. I'm not looking for 5 bushels. If I can get 10% on a regular basis from the use of a product, wet or dry, then I've got a product. And that's why I lean so hard on data, that then I know I'm getting paid. But we know that 10% of a 20 bushel pea crop, which I've had many times in Saskatchewan's, 2 bushels. So that means if those bushels are worth $12, I'm working with 24. And I've got to have a return on that investment. And if that input can be held down around that $10 range, I've got a $14 an acre return on that investment. But conversely, though, if I get a great pea crop, like they're alluding, like in really good weather conditions, and I'm up to a 60, 65 bushel pea crop, I still get that 10%. And now that 10% is 6 bushels to 6.5. So that's how I identify these ROIs, that there are a lot of biostimulants in the marketplace that talk about stress. Yes, they do help with stress. But I got to stress this point is in Western Canada, when I turn dry in mid-June and I go out there and I put a biostimulant on there, it costs me $10. 2 weeks later, it's still dry. I spend $10. 4 weeks later, 5 weeks later, I keep putting these $10 applications. Well, I can't resurrect the dead. If it's that dry, they don't have a return on investment. So I've got to be able to massage the applications and the timings and the rates to make sure when I do this, I've got an adequate return on investment, regardless of the climatic conditions. Next question.
Yeah, so this one is actually good because we had one just like it through email as well. They're asking, is there a maximum pressure that you can apply ACF, and can you kill the biology with too much pressure?
No, often I remember back in the days of working with some endophytes from a crew in South Dakota. And that's a very good question, because he didn't like to use a mesh screen any more than a 40 mesh screen because he was afraid of shearing the bacteria. This particular group of bacteria, there's no concern in doing that. It's not a problem. Pressure nor screens are an issue.
And just looping back to the email question as well, does the size of the sprayer nozzle impact anything?
No, it does not. No, it does not. I would think if I'm looking at moving down the road with some of the foliar applications, if my droplets are too coarse and I'm doing a foliar, I'm going to have a lot of droplet bounce. So in that, if I'm doing a foliar application, I'm after canopy coverage, then I do have to pay attention to my droplet size. But for ground applications that we use here, for instance, let's say in a tree fruit industry, or if I'm doing a ground application in a broad acre, and I just want product down, I can open up the floodgates. I just want a little bit of spread so that I'm hitting a reasonable amount underneath that crop. But that's the only reason I'd worry about droplet size is if I'm doing a foliar and I'm after a foliar application so I have better coverage on that leaf.
Awesome. And the final question here is, does it help with high salt that won't grow much?
Nah, no. You can have an impact, but I wouldn't say I found anything of all the things I've tested yet that will not succumb to the high levels of salt. It's an osmosis thing. So often in the springtime, I can get products to work initially, and that works for a certain time frame until I start to have a certain level of water holding capacity in that saline area of soil. And once you tip that scale too far with the water holding capacity, you actually start to draw moisture out of the plant because those salts are actually working against you until we find a material that's going to isolate those salts, or vice versa. Crops that will grow in those salts, like kochia out west, just love saline pockets. So this is none of the products I've got here are what I call a whiz bang effort to grow something in a substantial saline pocket. You'll have mitigated certain issues. The worm castings one, for instance, would have a better opportunity to doing something in that environment because it's a different composite of things. But the ACF, I don't see it having a huge impact. Moderately saline, absolutely. But those are moderately saline. So when you look at zodiac or saline soils, there are differences in there. So across that broad salty patch, I wouldn't say we can have a huge influence. Again, I'm not able to resurrect the dead. If it's not going to be able to grow, it's not going to be able to grow. You've got to address those with other materials. Super, I'll get back to my beginning. Okay, here is going to be one of those products. I didn't mention this before, but often products come to me because the industry want to help on establishing rates and timings of their products so they can pursue a label. This product was probably one of the very first that was ever brought to me probably almost 20 years ago to help them with all those moving parts because they'd had it for a long time and were treating it much like other products that were similar, but it was so different. They were overdosing. So this product, I refer to it as capturing the sun and releasing that energy because it comes from the tree industry, the paper industry. So the tree assimilates all this sunlight for years, stores it in the lignins of the tree. They come along, remove the trees, take that pulp and remove the lignins and make the lignojewel comes from that. So in that product, really simple, it's a manufactured by a polymer source derived from the pulp industry. It's a high energy molecule. So that's why it triggers soil and foliar and seed activity all on its own. There's nothing else but what they call a lignosulfonic. It's not a lignosulfate, it's a lignosulfonic. It's above any other material in its nature. So these 32% carbons really aid the plants and its ability to generate photosynthesis. And I know these things because when I'm working with a product and I identify certain benefits, I'll push it uphill, I call it, and I'll ask them to get scientific research papers done so that they can quantify that I'm actually getting photosynthesis, I'm getting mineralization and things of that like. So this particular product, it helps generate higher levels of photosynthesis. When put with fertility, it's a mineralization process, particularly with nitrogen. Then I can get standability because of the photosynthesis. I generate high quality at the other end because of all that influence. And the key to the producer, again, comes back to creating a yield that solidifies the ROI. If I spend more money than I get from yield, I don't have ROI. You have to have ROI for these things to be sustainable. Here's an example out of a research paper, and I'll draw to your attention the level of improvement from the photosynthesis in the branch. It's significant because branches in general don't do a great job. That's not their job to create photosynthase for the plant. That's the leaf's job. But I wanted to pull out here and show how it makes a difference in terms of the stems and the pods, because standability can be critically important. What's really intriguing and drives this picture and story home, I was working at a field day and I was there to show what it meant to be a biostimulant. And so I put the ligno, went on the flax crop 6 days before that show. And I'm at one of those little stations where I have plants on the table. So that crop was literally sprayed only 6 days before they were pulled for that show. And you look at that developmental root process. So, and that takes us back to influencing the rhizosphere. I generate the photosynthetates from improved photosynthesis. That's driven in through the root system as signals and information and food for the soil rhizosphere. And the plant goes on a feeding frenzy is what it does. And that's why the roots become so bountiful. That's why they pull up more nutrition and growth hormones to produce higher plant growth. And that's where the yield comes from. And that's where I start to establish my levels of ROI. So this is what it looks like on a stem. And again, I pushed this uphill to get scientific research because I kept seeing, crops were standing better wherever this was applied. And I was mystified. This would be years ago. So I had a research project done where they actually cross-sectioned the stems. And this is a cereal crop. You can see it's barley in particular, right? And wheat. You can see that the treated materials had a far better structured cell structure. Now, because if you go back to that slide where I showed the photosynthesis of the branch is so improved, I now get those stems to lay down a better structured cell and lignins, and that's where I get the standability. It's just simply because I've created photosynthesis on a part of the plant that's very inefficient, made it more efficient, and I get standability. And that's how this is what it will look like in real life in a field, whether it's corn or peas or wheat or whatever. And one of the key factors to think of this is, let's say, look at a corn crop. Then I go out there with put the ligno with a late season herbicide, and I'll create a little bit of standability, but the crop's probably only V4 to V6. But what happens is I get a little bit of standability then because there's a short plant. I only impact the stem I hit, but I also influence the early part of the ear development. Ear initiation is around that V4 to V6. So I go out there later on with a fungicide because of the other issues, and somebody's reapplying fungicides later. If I put the ligno with it then too, now I hit the stem on a greater extent. And I get up the rate a little bit, go to 3/4 of a liter, and all of a sudden I create a higher standability in that corn as it's maturing, and I get to ride the wave because they're out there with a fungicide. Those are key elements of pain points, right? I kept this slide in here. Has anybody noticed down the bottom corner, 2012? By golly, folks, that's soon to be 13 years ago this summer. This is when I'm putting it with nitrogen, and it's a liquid product. So by and large, it's always with UAN. And lignins love ammonia. So the first thing is a physical contact and compatibility with the ammonia and the UAN. Then when it's put into the ground, it generates this mineralization process. And it also reduces the impact of it interfering with the rhizosphere because of overloading the nitrogen, partly because I've done a physical thing and I've generated mineralization. And as everybody's looking at this photograph, and I use this on purpose, you're looking at it and you're thinking, look at how lush green that crop is on the right. That must be the treated side. When actual fact, it's the left side. And before I get questions as to why I think the left side's better, because of course, at this stage, the farmer was a little freaked and I was still learning about the mineralization. I've done it before, so I knew what to expect. I did a tissue sample on both sides. And on the left side, there was almost equal levels of nitrogen and potash, much higher levels of copper and boron. The other side was just jammed full of nitrogen, and it's lush and it's vigorous, and it's very susceptible now to lodging, to drought, because it has very little drought tolerance without the potash, and disease. So in actual fact, the left side is treated, and that crop went off to do a 12% yield increase on a 50 bushel crop. So it's really interesting to see these different types of things that occur. I just throw this in because I pulled some of the best yields from different applications, whether it's with a herbicide, a fungicide, UAN, done with a starter, done late season. It's a return on investment of a percentage. I want you to remember my thoughts on, if it's 8 to 12%, 70% of the time, that's on a 10 bushel crop or on a 60 bushel crop. I will profess this, though, with my work in Minnesota, years gone by. Once I breach a corn crop at 120 bushels an acre, because I've done some in Manitoba, the yields are low, I don't get that 10%. I have never seen 10% of a 230, 40 bushel crop of corn. It doesn't happen that way. That percentage starts to soften once that corn crop yield starts to breach that 120 to 140 bushels. Still significant ROI, but the bushels aren't generated on a huge percentage. So, James, if there's any other questions, I'd be more than happy to take it at this time.
I wanted to make a couple points here, Scott, and you may want to talk about this. With the Annalita, that was the original product you introduced. It's important for us as a company, if you have soil samples already, to send them over to us. And I'm happy to liaise on a call between Scott, myself, and your group, because knowing, your healthy pockets and your areas that need, different nutrition levels, we can actually diagnose that in detail. So we're saving you, if we need to use so much product as an example, we can cut nitrogen applications. Scott was mentioning, say 35%, but there's going to be certain areas where that needs to change. So this company as well, they can diagnose that fairly quickly. And then again, not overusing product is really the angle I'm getting at. It's the same with the ACF-SR. Again, that stands for AquaClean for soil remediation. In the background here, just so you're aware, with that product, we brew that product live here in Southern Ontario. It's got a 90-day shelf life, and it's only sold as a liquid. Again, going back to having a soil sample, it's nice just to have a reference, right? Just so that year after year, and our company's happy to go out and take a soil sample for you as well at the end of the season after applications have been applied. And yeah, like I said, that's the points I wanted to make. And going back to the emails there, reach out to us regarding pricing. These are inexpensive solutions as well. I can't stress that enough. We're here to save you money and also help you, maintain a consistent yield. And we're having a lot of success doing so. So again, reach out, and any one of us are happy to help.
I might throw one little last tidbit in for the participants who are there. Afterwards, if you come up with a question or a thought about even another product that I may or may not have tested, I'm always very interested in evaluating and studying and looking into the background of other products. There are a multitude of materials today in the industry, and I really want to impress people upon looking for data and making sure that things have proper labels going forward, so that it's not just a story, so that it's actual fact, that there's a reason to look into these, because some of the materials that I run across really shine, but a lot of them don't. So I always like looking into the background of them and putting the screws to them literally and testing them to make sure that what they're speaking to are actual evidence proofed. Thank you.
Thanks for watching our live discussion. Check the video description below for contact information and product links.